you're going to have something that looks like this. Might be a little different, your colors might be different or whatever, and that's okay. Right now, if I grab hold of this, move it, it turns quite nicely. Now you'll find though, some of you, if you don't have it quite right, and you turn this too fast, your piston will flip upside down and be in the wrong arrangement. And the only way to fix that is, of course, to delete the constraint and put it back on there. Now let's look at the constraints. Now, if we look at like this part right here, you can see I have it opened up, and it shows you the 3 constraints that are associated with that part. Now, that's one way of looking at the constraints associated with a given part. Most of the constraints you should have on this are either insert or mate. Now, you'll see there are 2 types of mate constraints. There's this first one here, that's a surface-to-surface mate. The other one is a surface-to-surface mate, but instead of being face-to-face, they're like this, they're side-by-side. Okay? So in other words, they're on the same plane. That's what that is. Insert constraints basically lock something in on center line and to a given shoulder or edge. You should have no motion constraints in this whatsoever. All right? We are not using the joint tool. We are using strictly the constraint tool. There's no motion constraints. If there's time in this semester, I will show you motion constraints when we make the set of gears. I'll show you how to time the set of gears so that they'll run correctly. Now, sometimes having all these constraints all broken up into different locations can be a bit of a challenge. If you go up here to this one called Relationships and you click on that, you will see all of your constraints in one place. Okay? Now, they're not in any particular order, but if you highlight one, you can see what it goes to. In this case, it goes to this hole right here in the back. It'll actually highlight where it's supposed to go. What we want to do right now, though, is to create a driven constraint, something that we can use to drive this wheel. Now, since it goes around a center axis, we can recognize its location in what kind of units? Degrees, or angular units, right? So, hence the little notch in there. That's your timing mark. All right? So, I'm going to turn this a little differently so it's facing this way. And then I'm going to zoom it up kind of big. Everybody see that? I believe so. All right, what we're going to do is we're going to put an angular constraint on here. So we go to our constraint tool. We pick angular, or angle, which is the second one right there. You click on that. Now you have 3 choices. The first one is basically an angle to an edge, or explicit thing. Undirected angles, which the second 2 here we very seldom use. I think I maybe used it once or twice in all my time ever using this. The one I usually use is a direct angle. In other words, it's direct to 2 given surfaces. So you click here. We click, if we go inside here, we click on the flat area here. Then we come over here, and we click on the flat area here. You hear that little pop. That means it worked. Okay? You hear that little pop. There it goes again. Somebody just did it.
In perfect timing, you said pop.
All right, then you click apply, and then cancel. Now I'm going to back this up. Now the thing is, it will no longer move. So that means that constraint worked. It took away that freedom of movement, that circular motion. Now what we want to do is go and find that one, and I usually, that's why I like to use this one, because they're in the order that you put them in. So it's this last one right here. We can see it's 0 degrees. I'm going to click on the word once, wait a second, and then click on it again. It allows me to go into the name change method, and I'm going to call it a driven constraint. All right? And the reason you want to put that in there is so that it's easy for you to find it. You know that's the one that's going to drive the whole assembly. What we do now is we right click on it, we come over here to the part called Drive, and since it's now an angle, we can actually tell it move in an angular direction around that axis, which of course would be the center axis of this shaft right here. So I'm going to open this up so you can see the whole thing. There are more items here. You can see drive adaptability and collision detection. You can actually use that. You could actually have this so that piston comes all the way to the top, touches, and then goes back and down. You can drive it that way if you wanted to. Very difficult way of doing it, especially if it doesn't touch, or it doesn't come up just far enough for it to be able to come down the other side. So you could actually end up having your wheel go back and forth. So actually using the angular one on this is probably the best. You can record your little video if you wish to, once you get everything set up, by just clicking the little red button. And you can make a little WMV file of it and put it in a PowerPoint or something like that, just to have a little fun with it. These are very simple animations, okay? These are not animation quality like you would get with 3ds Max or Maya or something of that nature. But they do work. So we're not going to put any drive adaptability or collision detection in here. We're going to change this to 360 degrees. I want to go start, end, start. Yeah, I believe that's it. And then I'm going to change this to 5. So that means it's going to do it 5 times. I'm going to change my degrees of rotation. Basically what this is going to do is it's every second it's going to move so many degrees. And in this case, I'm going to have it move 5 degrees. All right? You can see we have an AVI rate here of 10. That's 10 frames per second, which is, you can actually bump that up if you wanted to 30. That would be basically television quality, but it would be a very large file. Okay? So once I have that in there, I can come up here, and then I have basic video player play items. I'm going to back this up a little bit so you can see it. And if I did this right, it should go around in circles. Notice mine's going back and forth. Why do you think it's doing that?
Start and start?
Because it's start, end, start. If I go to just start, end, and hit rewind, it should go all the way around in a circle. And if we look, we can see that the engine is, all the pieces and parts are moving. It's kind of a neat little thing. You get to see it actually operate. And that's one of the reasons why I like doing this project. Because we can cover a lot of different things with it. So that's how you animate a project. It's pretty simple. If you build it correctly, you should only have to move one item to be able to get it animated. Now, more complex parts, of course, there's more to it, where you're going to have to do more with it, using motion constraints and stuff like that. That's for 242 when we start getting into that kind of stuff, okay? This is probably great just for certain things, and also this would make a very good portfolio item because you're showing that not only can you do fundamental block modeling, you can do assemblies, and you understand how to make something move, meaning a driven constraint. Okay? So if you wanted to put this in your portfolio, I would recommend you do that. All right, so that's that. Now, how do we send this printer to me? What you do is go down here to the folder. I'm going to close this up. By the way. You come down here to the folder, and you'll see I have this one folder called Pip Squeak Engine. So when I go here, I should have a folder called Pip Squeak Engine. This is really actually very easy. I right-click on it. I say Send to Compressed Zip Folder. All right? As you can see right here, I send to Compressed Zip Folder. Now, if you send it to me just as Pip Squeak Engine, guess what? I'm not going to know whose it is. And I'm going to have a whole bunch of them go in there, and guess what happens when I process them? If I have 5 or 6 of them with the same name, guess what happens? I end up with one, the last one. And then I got to go back and figure out who's is whose. That makes me a grumpy person, okay? So let's not do that. So what you would do is actually compress the folder. And it may take a moment, but it shouldn't take too long. All right? Now, you'll have a folder with a zipper on it. Okay, that means that it is zipped. If we look at it with a right click, you can see that it's not very large. It's only about 18 megabytes. My email can handle something that large. All right? In actuality, yours will be a little bit smaller because you won't have all the PDF files in there. So take the PDFs out. All right? Don't leave them in there. Just take them out. Okay? If you have them in that same folder. Take anything that doesn't directly deal with the engine, in other words, an inventor file dealing with the engine, out. You might even want to clean out your old version folder if it's kind of full. But it's not necessary. As long as it's under 20 megabytes, my email will pick it up. All right? So what I want to do now, though, is I want to change its name. So I right-click on it, rename. I keep the Pip Squeak Engine part, but what you do is you put your last name in there. I'm going to use mine. Please don't send me a bunch of them with dire Pip Squeak Engine. All right? That's all you got to do is put your last name in front of it, underscore, and send it to me. You don't need the CAD 241 or anything like that because I don't have a second 241 class or a 242 class. So I don't need the CAD 241. I know it's going to be from you. Okay? So you do that, click on it, and then just attach to an email as you normally would. Okay? You send it to me as an attachment. Any questions? I know you have a dozen of them over there, and you don't want